Hi everybody, this is Raw again with another Kerbal Space Program video. This is episode 2 of my Interplanetary mission. And now that we've finished making this thing, I'm going to see if it gets into space. I already know it can take off, I already designed it. And for your viewing pleasure, I will fast forward till it's daytime. This flying at night crap is just not working for anybody. Especially Jeb, ain't that right, Jeb? Wow, it must have been just after sunset because that took forever. Okay, here we go. So I'm going to hit 3 to close all of the bunch of intakes. Full throttle, lights on, and spacebar. So last time, what was it, about like at 80 some that it took off? Yeah, actually after 90. There it is. Okay. We're not going to muck about. We're going straight into space. All those intakes there. It looks like it's wearing a backpack, doesn't it? Like a bulletproof vest with the ones on the front. I don't know. Overactive imagination and whatnot. Can it do time acceleration? Why, yes. Yes, it can. That's good. That'll cut down the time that you guys have to sit here and watch me, you know, come up with filler comments and whatnot. What I'm interested to see in this maiden voyage, so to speak, into space is how much of this fuel is actually left over. I'm hoping that's about as much as it's going to take to get there, so I don't have to take any oxidizer out of these and take, you know, empty tanks or whatever. Well, let's see. Okay, we're getting up there. Let's open the rest of the intakes. Got good speed, even at this high angle. That's great. Let's start flattening out and picking up some speed. Let's see how the time acceleration does with that. Well, but I'm about to start losing altitude. Let's see. This seems a little heavy for the wings that it has. It's probably a little inefficient because of steering loss with all this weight and just those 4 wings. Okay. Here we go. It's going fast and high. Let's see. Okay, so our intake's not bad even without time acceleration. Let's flatten this out and pick up more speed than altitude. My hope with this is that I can, through just burning really high and really fast, get an apoapsis already pretty far out in space just off the air-breathing engines, and then just circularize with the atomic rocket and be good. I'll see. Picking up speed rather well, and I don't have to pick up too much more altitude. Time acceleration. Let's keep it at 2 times. I'm not gonna go crazy here. Okay. Still climbing, still picking up speed, still good intake even though we're cheating. You're not really cheating. I mean, if I cut that, it'd still have more than enough air. Let's just see. Okay, so I'm starting to hear that little whine that normally tells me the engines aren't doing so well. So let's take a look. I haven't desynced yet. That's good. This is one of the reasons why, even though they're not necessarily, or they're not 100% necessary, the control wheels are a good idea. Because, yeah, the fins are going to keep us flying, but when we start running out of air, the control wheels are what really steers us. And when we start desyncing the engines, the control wheels can kind of keep us in line. We are moving at good speed, so I'm liking this. This is looking good. Let's flatten down and really get going fast, because we're nice and high. The atmospheric density here is really low. You can speed up like crazy. Engines still haven't desynchronized. That's perfect. I'm gonna start losing altitude though. Okay, so you probably want to be... It's going to change the orbital view, and then it's going to be way faster than this. But we definitely want to get this somewhere above 2100 on surface. The orbital will be faster. It'll be like 2300. But we're on track. We're in good shape. Still got a little, but enough air. Still picking up speed. Still picking up altitude. Still symmetrical on the actual thrust. This is what desynchronizes this number. The rest of it doesn't really matter. But this is where you start seeing the disparity. Okay. Above 2,000 meters per second. That's great. Losing thrust. We're starting to go so fast that we can burn flat and not lose altitude. Our our apoapsis is probably starting to stretch out the other side of the planet. Let me see that. Yeah, it's going pretty well. This is where it's going to start to desync. I have to keep an eye on it. So far, so good. Still climbing. There it is. It's desyncing. I'm going to throttle down a little bit. But not so much that we don't keep gaining speed and altitude. Okay. Still moving up. Still going faster. Okay, see, when I change the orbit, the numbers really go up, because now it's not measuring our velocity in relationship to the ground, which is spinning in and of itself in its own direction. Now it's more like measuring our spin versus the center of Kerbal or something like that. Desynced again, so let's drop that. What I don't want is I don't want to be losing velocity, which I am. So when you get to that point where you can't accelerate anymore because you don't have enough air, that's when you kind of have to switch over to the rocket. I'm sort of getting there now. I can't stay synchronized and accelerate very much. At this throttle, I'm barely picking up speed. I'm still kind of in synchronization. That's not bad. Let's let that happen a little while longer. No, but I'm barely picking up speed. Let's not do this anymore. Okay, 3 to shut down all of them, 1 to shut down that. Turn off the engines. Put it back to full throttle, and fire. And let's see how that's looking. Apoapsis 80-some, 90-some, okay. Let's put it at 100. We're pretty high up already. Okay. So now we are coasting. Looking for the magic 70. More time acceleration. Still in the 80s, that's not bad. Keep it pointed, flat. There we go. We're in the 50s. It's in the 70s. My problem when it gets this low is the apoapsis, the point of 70 kilometers is coming down closer and closer to me, which means that every bit this lowers means more atmosphere I have to go through. Let me give it a little bump up. Mach to 90, okay. So that means that I'm going to hit 70 sooner because I'm on a higher angle out. So I could have coasted a little further, but I didn't really want to have to go through all that atmosphere between here and there. See, already I'm about to hit 70 right here, which even though I had to select the higher apoapsis, makes this a little bit more efficient. Cue the music. Here we go. Alright. So we're at 91. I'm going to circularize this at 90. It's almost 91. 90.6. 90.4, that's fine. 90.4, K-Raw radio. Sounds like a radio station, doesn't it? 88, 90, 89, I mean 92, sheesh. That's good. Oh, time acceleration, yeah. Estimated burn in 19 seconds and about 2 minutes. Okay. I have no idea why. I always do these from outside. I never do them from the map. And as usual, even though I time accelerate to be in the day, I'm in the night. Yay! Let's do this in the dark. Fine. So at exactly 10 seconds, I will fire on the engines at full throttle. Here we go. Okay, let's look at that orbit. 89, 90. Guess what? Just to be a complete tight ass, let's... Okay, good. So there we go. Circularize orbit. Let's do a... Well, first of all, let's get this thing back into the sunlight. There we go. Okay, so let's see. It says it has a lot of fuel after all. Let's see exactly how much. It's not showing me that because it took it out of there. Let's pump that back in there to see how much of this actually was used. This will make it symmetrical, right? So pretty good. I mean, we used, I think, a little tiny bit more oxidizer than liquid fuel. Yeah, there's a little difference there. But that's fine, because you never know when you might need a little extra liquid fuel on the return trip. You know, if your return trajectory doesn't line you up exactly to the runway. So having, I mean, that's literally nothing. It's what, let's see. Pulling out the old trusty calculator. So we have 353, and that was divided by a factor of 9. So it's 39.2 units. Versus the oxidizer was 421 divided by 11. 38.2. It's a difference of 1 unit times 9. So I have almost exactly 9 extra units of liquid fuel in each tank. So 18 extra liquid fuel after making it into space. That's great. I'm very happy with that. So I'm gonna go ahead and sign off here, gentlemen. This time I'm not gonna say flight safe unlike me because I didn't crash. Haha. Still, I think next episode to test how well this thing flies in space, I'm probably gonna try to fly it to Minmus, land on Minmus, fly it to the moon, land on the moon, and then make it back to the Kerbal Space Center and see how much fuel I have left over. So for now, thank you guys very much for watching, and this is Ross signing off from orbit.